Hey guys, welcome to Unit 6, Lesson 4. Our topic today is factoring the sum and difference of cubes. So pause the video, try the do now. So here, again, it's asking us to factor completely. The first rule is to always look for your GCF. So your GCF here is 2x, and you're left with x squared minus 36. So now look at the inside. You must always check, especially the word completely means that there might be more than one type of factoring. So these are two terms, they both happen to be perfect square and there's a minus sign in between, so difference of squares. So I'm going to set up, how do we do this? Set up two parentheses, once with a plus, once with a minus, and you're basically taking the square root of each one, so it'll be x. Do not change the order because x was your first term, so I wrote x. And square root of 36 is 6. Bring down your GCF. So this is factored completely. So let's get started with the lesson. When we factor first, we always determine if there is a GCF, right? Then if we have two terms, we use dots, difference of two squares, right? Which we did that for the do. Now also, we're also going to add this to our list now. Difference of, which is our lesson today, difference of two cubes. And we'll talk more about it in a bit. Three terms, you use your AM or AC method. If you have four terms, you use grouping. We've done all these different kinds except for difference of two cubes. So that's what we're going to be exploring today. Now we will explore factoring the sum and difference of perfect cubes. So yeah, I should write sum and difference. I didn't write sum and difference of two cubes. So remember, perfect cubes are, what's a cube? Any number to the third power, right? So one cube is just one. One is perfect square, perfect cube. So that's why we didn't include it in the list. So 8, 27, 64, 125. If it makes you feel comfortable, you can write this is 2 cube, this is 3 cube, 4 cube, and 5 cube. And you can go on. Variables are perfect cubes if their exponent is divisible by, what do you think? 3. Factor the sum of perfect cubes. So this is how you factor it. But I want you to pay attention to the letters. Look at this. This is A, B, A, B. No matter what, A square, A, B, B square, B square. So no matter whether it's sum of perfect cube or different, you go in the same order. It is the signs that you have to be very careful about. We use SOAP. And I'll write that S-O-A-P. What does that mean? S stands for same sign as the question. So if it's sum, it's going to be positive. And then opposite sign, I'm going to write same sign, opposite sign, and the last term AP, we write it together. It's always positive. That's how we do this. So let's jump onto a question and see how it goes. So I'm going to again write my perfect cubes on top of the page. So my perfect cubes are 1, 8, 27, 64, 125, and 216. I'm just going to go up till 6 cube. So look here. This is my A cube minus B cube. It's a difference of cubes. I'm going to actually write down the formula, which is A cube minus B cube. And if you choose to put it in parentheses, it'll be so much easier. So would you agree that A is your base and 3 is your exponent, right? So what you do is you write your bases first. Always again, check for your GCF, which in this case, it's not there. So it's going to be your bases A and B. And then you do A square, multiply the 2AB, and then the B square. Now use your SOAP that we learned, S-O-A-P. SOAP means same sign, so it's going to be negative. Opposite of negative is positive, and this is always positive. So this is how you determine this. Now I'm going to try to write this as A cube and B cube. X cube minus, what is 8? 8 is a cube root of 8 is 2, or I can write it as 2 cube is same thing as 8, right? So on the side, can I say my a is my x and my b is 2? All you can do is substitute it. I would highly recommend you writing down the formula and then just substituting. And so it would be what? X minus 2, or you can do the signs later. And then let's do the signs later. We're going to use SOAP again. So this would be x squared, 2x, 2 times 2 is 4. And it's going to be same. Negative, I'm going to take a different color. Negative, positive, always positive. So this is it. You cannot factor this further. Actually, if we were to talk about our roots, this will give us our if you factor this, you will end up with complex solutions, which we are not discussing right now. We just need to factor it, okay? So the next one, again, I want to, again, write down my sum here, sum formula. So it's going to be a cubed plus b cubed. Put your parentheses around so if it's easier for you to see. And let's write this down. It's a, b, it's the bases, and then a square, ab, b square. Use SOAP to determine your signs. So SOAP, same is positive. Opposite would be negative, not positive. So negative, and this is always positive, right? So now, can I rewrite this? Again, remember your variable must be a multiple of 3. 6 is a multiple of 3, right? 8 is a perfect cube. 125 is a perfect cube. So you have to do that check step. So can I rewrite this as 2x squared to the third plus, this would be what? Written as 5 cubed, right? So now my a is what? 2x squared. And my b is 5. So all I'm doing is substituting in. So it'll be 2x squared, and I'm going to do the signs later, 5. And then it is a squared. So be very careful. I am actually going to write 2x squared, and I'm going to square that. This is one very common error that I see students make. And then you can just write it. You don't have to actually multiply in the first step itself. AB and b squared is 5 times 5 is 25. You can choose to write 5 square, or you can write 25. And now do the signs. It's same, opposite, always positive. Now let's simplify this a little. This is 2x squared plus 5. This would be 4x to the fourth. Okay, many times what I see is students will forget to square the 2, and that's where it'll be wrong. And then 10x squared plus 25, and that's your final answer. Okay, the next one, I want you to try and pause the video and try the next one. Okay, again, check for your GCF. Is there a GCF? Oh, there is a GCF, which is what? 7. Oh, so 7 is my GCF. What am I left with? 8m cubed minus n cubed. Now check. There are two terms. They're not perfect squares. So let's check for perfect cubes. They are perfect cubes. 8 is a perfect cube. M cube is a perfect cube. There's a negative sign, and n is also a perfect cube. So can I rewrite this as 2m cube minus n cube? I know my a. I'm going to leave my GCF out for a while. I'm not really worried about my GCF, right? So put this parenthesis. So my a is 2m, my b is n. So again, I'm going to write down my formula. So it is a cubed minus b cubed. It is a minus b. Eventually you will, trust me, once you keep writing your formula over and over again, write your formula for each question, you will have it memorized by you finish this lesson. Plus ab plus b squared. That's what it is. So let's do this. I'm going to bring the 7 later. So this is going to be 2m minus n. If you want to do the signs later, we can do using SOAP, which would be another good practice. And then it'll be 2m squared 2mn and n square. Let's do the signs same, which is negative, opposite, positive, always positive. And now bring down the 7. In the next step, let's finish it off, simplify it. So it's 2m minus n. I know some of you will feel like, why do I have to do that extra step? If you don't feel like doing that extra step, go for it. Just do it in the first place itself. But to avoid all those silly errors, we're trying to do it together. 2mn plus n square. Up. That's what happens when I work in the bottom. Oh, there was more room. Okay. So I want you to try the remaining questions on your own. If you have any questions, please contact your teachers.